Hello dear student, myself Kanchan Vishramji Kumbalkar, Assistant Professor, Sri Shivaji College of Arts, Commerce and Science, Akola. I am here to deliver a fifth lecture of thermoanalytical method. So let's check out. This is the overall syllabus of thermal method of analysis. In overall, out of which the introduction of differential thermal method, TG and DTG, instrumentation, factor affecting thermogram, application of thermogravimetry, we concluded in previous lecture. In this lecture, we are going to discuss about the derivative thermogravimetry. Now, what is meant by derivative thermogravimetry? There are basically two different types of gravimetry comparatively discussed in this lecture. First one is the thermogravimetry, that is TG, and second one is the DTG. TG means it is simple when we are comparing a weight versus temperature, then it is considered as the thermogravimetry. Means in thermogravimetric analysis we put the weight factor on y-axis and on x-axis we put the temperature. But in a derivative thermogravimetry, we put the dW upon dt, that is a rate of change of weight, means the change in weight with respect to the time has been plotted on y-axis and the temperature has been plotted on a x-axis. So that type of thermogravimetry is nothing but a derivative thermogravimetry. The derivative curve may reveal information that is not detectable in an ordinary thermogram. Thermogram is considered as a quite simpler method to identify a weight loss, but to differentiate various points, peak points, the various steps in a reaction of decomposition of a particular material, the derivative thermogravimetry give a clear idea. So that's why the derivative curve may reveal more information which is not detectable in an ordinary thermogram. This point has been illustrated by comparing a TG and DTG curve of a compound, that is copper sulfate pentahydrate, which has been shown in the figure 1.6. So let's check out first of all the reactions. Now we are considering a one chemical, that is copper sulfate pentahydrate. This is your starting material. We have to discuss here the decomposition of copper sulfate pentahydrate from that of the room temperature and up to the 1200 degrees Celsius. These are the various 6 reactions, 6 steps has been occurred in between room temperature to the 1200 degrees Celsius. This is the decomposition of copper sulfate pentahydrate. Now let's check out the first reaction. When the temperature is reached up to the 90 degrees Celsius and when the temperature is in between 90 to the 150 degrees Celsius, the copper sulfate pentahydrate get decomposed into the copper sulfate trihydrate with a liberation of water gas. Water molecules has been ejected here. Means the first weight loss has been observed. Second weight loss or the second reaction occurred when in between the same temperature range, but the successive second step has been occurred, that copper sulfate trihydrate get converted into the copper sulfate monohydrate with a liberation of 2 moles of water as a gaseous state. So in a same temperature range, that is in between the 90 to the 150 degrees Celsius, this has been get converted into, means copper sulfate pentahydrate get converted into the CuSO4.H2O with a liberation of 2 moles of water molecules successively in a 2 step. Now we are moving toward the third step. The third step occurred in between a 200 to the 275 degrees Celsius. The second reaction is that the monohydrated copper sulfate get converted into CuSO4 with a liberation of H2 as a gaseous state. In a fourth step, this CuSO4, the product of third step, get converted into with a liberation of SO2, O2 and the formation of solid state of CuO with a CuO dot SO3. This complex, yellow colored, golden colored complex has been formed. But it is occurred in between a temperature range of 700 to the 900 degrees Celsius. Means from that the 75 degrees Celsius to the 700 degrees Celsius, the compound is quite stable and it gives a, there is no any weight loss, so there is a plateau has been observed here. Similarly, the fifth reaction occurred where the CuO.SO3 get converted into CuO with a liberation of SO2 and O2 in the temperature range of 700 to the 900, and final decomposition occurred in between a 1000 to the 1100 degrees Celsius. In this last step, the CuO get converted into the Cu2O with a liberation of O2. So theoretically, it has been observed that when we are heating a copper sulfate pentahydrate from that of the room temperature to the about 1200 degrees Celsius, following different 6 steps has been observed. Now let's check out its Tg curve. This is the Tg curve for this overall decomposition of copper sulfate pentahydrate. But in this Tg curve, there is nothing any differentiated 6 reaction weight loss has been observed. There are only 2 points, means there are 2 slope, one and second. This is first slope and this is second slope. Obviously there is a differentiation, but there are only 2 observation has been there. This is the range of about 275 to the 700 degrees Celsius range where there is no any weight loss. Again there is a weight loss takes place in between the 700 to the 900, and then again 1000 to the 1100 degrees Celsius. And this is the temperature range from that of the 90 degrees Celsius to the 150, and then 150 to the 200 275. So this is only the 2 point has been observed. What it indicate, this Tg curve, what this Tg curve indicate? The Tg curve in this case does not reveal all these changes clearly. For example, the Tg curve give an impression that CuSO4 5H2O gives rise to CuSO4 and 3H2O in a single step. However, the inflection point B arises due to the formation of CuSO4 dot 3H2O. This B is because of the formation of CuSO4 trihydra from that of the CuSO4 pentahydra molecule. Similarly, the TGA curve makes it appear as if CuSO4 gives rise to CuO and SO2, CuO and SO2, and half O2 has been get lost in between 700 to the 900 degrees Celsius. Similarly, but the C point is because of the formation of 2 molecules of CuO and .SO3. So because of the formation of the C point is corresponds to the formation of a golden yellow basic sulfate having the composition of CuO.SO3. So on the basis of this TGA curve, we cannot indicate that what is the exact different steps of reaction has been occurred in the decomposition of copper sulfate pentahydrate. Now comparatively, let's check out the DTG curve. This is the overall explanation. Now this is your DTG curve. Now in this case, in DTG curve, there are overall 6 peaks has been observed. 1, 2, 3, 4, 5 and 6. Means it clearly indicate that during the decomposition of CuSO4 5H2O, copper sulfate pentahydrate, there are the 6 various steps has been observed. First step is in between 90 to the 150. This indicate this one. Second step is related with that of the This is related with that of the again the same temperature, that is 90 to the 150 degrees Celsius. The second one is a 200 to the 275 degrees Celsius, third step of reaction. Fourth step, which is fourth step and fifth step, which is occurred in between the temperature of 700 to the 900 degrees Celsius, and this sixth step is related with that of the 1000 to the 1100 degrees Celsius. Now these are the points. This is the six different peaks has been observed. It clearly states that there are various six steps has been observed where the rate of change of weight with respect to temperature has been get differentiated in a same temperature range also. So the first point, the single B point, which is because of the formation of CuSO4 3H2O from that of the pentahydrate, is indicated as a B in a TG curve. In this DTG curve, this is your B point, that is in between the first and second step. In fourth and fifth step, there is a formation of, we indicate this is the C point. This trough is considered as the C point. So this trough is the trough between the first and second peak is considered as that of the, because of the formation of copper sulfate trihydrate, and the trough in between the fourth and fifth is counted as a C, which is comparatively means which is equivalent to that of the TGA curve. The TGA curve indicating B and C point is exactly observed and clearly observed in DTG curve in such trough point. So this is all about the DTG curve. This is overall explanation. Means in this case it can be noted that the inflection point B and C of the TGA curve are revealed as shallow trough between the peak first and second and peak 4 and 5 respectively. So this is all about the TGA comparison with a DTA as well as the differential thermogravimetry and its explanation. In next lecture we will start with that of the differential thermal analysis, characterization and representative example of DTA curve. Up till then, take care, be safe, stay safe. Thank you.